This is a longer, more detailed version of the short video showing how to save ToolPath templates. So currently we do have ToolPath templates saved, and each of the ToolPaths included in this job are listed in the ToolPaths tab. So we have the cut, drilling, and an inside cut. We are going to take a look at how to set the order of which gets cut first, take a look at tool naming, the depth per pass, step over, the tool offsets, learning about the calculate button, clear toolpaths, and saving the toolpaths. So we'll start off by clearing the toolpaths that we've already have calculated. And we will first take a look at the cut order of what operation is going to get cut first. The operation order is based on the order that is showed up in this list here. Holding the Shift key down and clicking and dragging a part or a feature in the list is one way to reorder what is going to get cut first and what is going to get cut last. So in this case, we have the inside first, drilling, then the cutting. To automatically set the order on what each operation is going to get cut first, that is in the order of setting of the ToolPath template. So currently, selecting on each one of these, the cut order or the order is the same. The value with the lowest value is going to get cut first. So if we want to have our drilling cut before anything else, we're going to set the cut order to 0 and come down, save that as a template. If we want the next feature to be the inside cut, we're going to change the cut order here to a 1 and save that as a template. And the cut is already set to 3, which is greater than the 1 or 0 of the other two operations. Once we've saved this as templates, once we calculate a new job or renest, the order of the operations are automatically going to be dictated by the cutting order of that ToolPath template. So as we see now, the drilling is first with the order of 0, then the inside cut, order of 1, then cut. This could be an alphanumeric number, so it could be A through Z as well. Just remember that numbers come before letters. So if we set the drilling to A, that is actually going to show up in cut last. Again, made that change, going to nest. We now see that they're cut in a different order. So we could change the other ones as well. So A gets cut first, then B. Remembering to save this template after each change, then C. So now they are listed as A, B, and C. Renesting are going to show that order as A, B, and C. The next item that we're going to take a look at is the calculate button versus just saving toolpaths. The calculate button allows us to get a quick preview of what the toolpaths are going to be without actually saving the files for that job. So it just allows us to calculate and see what that toolpath is going to be like. And as we zoom in, we could see that the inside is in fact cutting to the inside. The outside is cutting to the outside, and we do have points for the drilling operations. Clearing those toolpaths is going to clear all of that out, and just clicking Save ToolPaths does the operation of calculating and saving the ToolPaths. A couple features that we could take a look at when cutting and setting up the layers is the lead in and ramp distance. The ramp distance is a angled ramp into the cut. If we want to make that over a distance of 1 inch, with the cut layer selected, ramp distance of 1, saving that as a template. And we could see what this looks like by just calculating without saving the toolpaths. We could see this ramp by clicking the orbit and rotating our sheet around. And this is the ramp into the material. We could also add a lead in. This is set by degrees. This is going to allow that ramp to not be directly over top of the line, but offset just a little bit. And we want to take a look at the direction of that. So right now I'm just going to put in 5 degrees. First selecting the layer that we want that to be associated with, setting that to be 5 degrees, saving as a template, then calculate again. We don't need to clear the toolpaths. The calculate automatically clears and recalculates all of the toolpaths. The lead in can be a negative or a positive number to change the direction of what that lead in is going to be going with. So currently we could see that lead in right here is onto the inside of the cut, which means when we cut this, we might get, or we will get, not might, we will get a little bit of a nick or cut into the part itself. So that lead in for the cut layer should be a negative value, to be negative 5 degrees. And this negative positive depends on, are you conventional cutting, climb cutting, or cutting from the inside or the outside. So with that change, again, clicking Save as Template, and calculating that toolpath. We will now see that that angle is to the outside. You do need to be careful to make sure that the distance or the ramp distance in this angle does not create an overlapping line into the previous parts. The cut depths of each of these objects or vectors are based on the DXF elevation. So as they are imported, we could see by clicking on one line and coming over and seeing the bounding size that Z is going to a negative 3/4 of an inch. So for this cut layer, it is going to cut down to 0.75, which happens to be our material thickness. We may need to cut a little bit deeper than 0.75 to cut all the way through. This is the add to depth. We could add 0.02, and yes, that needs to be a number, 0.02, and saving that as a template. We're not going to see any difference here because it is only going to change the depth of that cut by 0.02 inches. It's all going to look the same as far as our toolpaths go. But once it is done and calculated, just as we clicked on one of the lines of the cabinet, we could select the toolpath itself and now see that the Z for that toolpath line is down to a minus 0.77, 20 thousandths deeper than 3/4 of an inch. Setting an onion skin for a toolpath. An onion skin is a way to cut and help with hold down to allow us to cut almost all the way through, setting a checkbox here, saving as template. This onion skin is also dictated by the settings and the area. So with the area set to 4,000 or 400, only parts of a 400 square inches or less, or if we were set up in metric, only 400 square millimeters or less. So metric, you'll have to make this number a little bit bigger. That was a little bit more in-depth video on calculating and saving toolpaths.